this last section of the set material is a little bit different, even just from the name. Even just from that they're called survey problems. You think, well, what does that mean, right? Just looking at the titles, that one feels like it doesn't fit. And survey problems are a little bit different. The way that they're different is that you don't know the individual elements of the sets. You just know how big they are. So like you have their cardinalities, and you can kind of do things with that. But if you don't know what the individual elements are, there's no way that you could like write out the individual sets using the roster method, right? I mean, that would be impossible, right? What would you list if you didn't know what the elements were? So that's the part that's a little bit different. So like it says up here, survey problems, they're ones where you can't list the individual elements of a set because you don't know what they are. But we're still interested in the cardinality of some relationship, like either for maybe an individual set or like an intersection of two, or maybe a union of two, or if you have three, maybe the cardinality of the intersection of two of them, but not including the third one, something like that. So it works kind of the same way as what we've been doing, but what I would say with these, with the survey problems, I think the picture, so the Venn diagram, it's very, very, very helpful. That really helps a lot to keep track of everything, and I would generally draw them, especially because you really have to watch out with these sorts of problems for how many individuals are outside of the union. So like in the picture, like in the Venn diagram where they'd be inside the rectangle but not in either of the circles, you got to really be careful about that, and the easiest way to be careful about that is to actually draw it. Right, because effectively that functions like a check, because then if you don't have a number that's in the rectangle but outside the circles, you go, wait, am I supposed to have something there? Right? So then that way you have like that mental check built in too, which is good. But number one, you could actually do this one without the picture. So I'll show you how to do that first, and then we'll do it with the picture. So it says out of 100 people surveyed who are traveling to a lake, 45 are planning on going fishing, 60 plan on going swimming, and 20 plan to do both. All right, so if F is fishing and S is swimming, then I think what we've got is that we know, it would help if I turn this on, that the number who are going to go fishing is 45, and we know that the number who are going to go swimming is 60. And then both is an and, right? Both would be fishing and swimming, but in terms of set notation, and translates to an intersection. So the cardinality of F intersect S is going to be 20. And the thing that you could use, and this showed up a couple of sections ago, is you could use this idea that the cardinality of the union would be equal to what you got if you added up the individual cardinalities of those two sets, but then subtracted out the cardinality, the intersection. And the reason you got to subtract out the cardinality, the intersection, is because here, after you've added these two together, basically you've counted the intersection twice. If you think about like a Venn diagram, you would count the overlap twice because it's part of this, it's part of F and it's part of S. So you got to subtract it out so that way it's only being counted once. But then you could figure out the answer right from here and just say, well, this is 45. The next one is 60. Then we're going to subtract off a 20. So 45 plus 60 is 105, and then minus 20 is 85. And that should be the answer. Okay, that's one way of doing it. The other way to do it, which maybe I wrote too big, but I think I could squeeze this in. It's only a 2-set Venn diagram. If it was a 3, I'd be in trouble. All right, so there's our universal set rectangle. And then fishing, swimming, universal set. And when you build the Venn diagram, kind of like when we talked about before how it's better to work inside out, I still think that's true. So I'm going to take care of the overlap first, and that's the both, right? So we know 20 have to go in there, right? And this is how you make it for a survey problem. It's just whatever the cardinality is, you just put that into the Venn diagram. So my cardinality of the intersection is 20. I'm just putting a 20 in there. But then to get these, we know that the cardinality of F is 45, right? It said 45 plan to go fishing, but that's for the entire F circle. So there's got to be 45 within the F circle, which means that here you got to have 25, right? Because this is part of the F circle, but so is this. So then 25 plus 20 will give you the 45. And you do the same thing over here, where we know that S is supposed to have 60. There are already 20 in the overlap, so the rest would be 40. So that way you get the 60, right? Because 20 plus 40 will be 60. And then the other thing you got to check is, and I guess you don't need it for this particular problem because you can actually answer it from here, but is there anything outside of the circles? Well, we know that there are 100 people surveyed. So do these add up to 100? Well, let's see. 40 and 20 is 60, and 25, 85, no. There's an extra 15 to get up to 100. So there must be 15 people in the universal set, but not in either of those circles. So they're going to the lake, but they're not going to go fishing or swimming, right? They're just going to go there and hang out or do something else, right? So that's, in this problem, you don't really need the 15, but generally it's a good idea to put that in there if you've got any individuals that are in that situation, right, where they would be in the universal set but not in either of these. So that would mean that, I guess if we were going to do it from here, that then the number going fishing or swimming, basically you can just add up, because fishing or swimming, that's the union, so it's going to be 25 for the people who are just fishing, so just an F, plus 20 for the overlap in the Venn diagram, plus 40 for the part in the S circle that's not in the overlap, and if you add that up you get 85. So same thing as up here, which is the way it's supposed to work, right? If you use the Venn diagram, or if you use this rule that we had earlier a couple sections ago, you're going to get the same answer. All right, good. Number 2. Look at this. 51 own neither, right? That's kind of a new thing this time, because the last time it was just we were given the fishing and then the swimming and then the both. This one we're given owning a dog, owning a cat, owning both, owning neither. So the owning neither is going to be within the rectangle but outside the circles. So if I draw the Venn diagram here, I got a lot of room for this one. All right, so I guess we just need the 2 circles again. So dog circle and cat circle. So just D and C for dog and cat, I suppose, and then universal set. All right, so working inside out again, the overlap, that's the intersection, so that's the both, right? It's owning a cat and owning a dog, and so the and is going to translate to intersection. So the 12 goes in there. And then we kind of end up what we did last time, where if we know 35 people owned a dog, so there's got to be a 35 in the D circle, but there are already 12 in the overlap. So that means that you'd have to have 23 over here, right? 35 minus 12. So then that way when you add these two numbers together, you get the 35 in the D circle like you're supposed to. And then with the cat, same kind of thing. 48 total in the C circle, but we know there are 12 in the overlap. So you'd have to have 36 out here, since that's what 48 minus 12 is, right? And then you add these two together and you get the 48 back. And then the other thing is 51 own neither. You know where that goes? Out here, right? I guess you don't have to put it in any specific spot in the rectangle, just as long as it's in the rectangle but outside those circles. So how many people were surveyed? Well, it would be just dog plus just cat plus both plus neither, right? That exhausts all possibilities here. So the number of people surveyed we can figure out by just adding up those 4 numbers. So 23 plus 12 plus 36 plus 51. Let's see, if I do this in my head, that's 35 And then the last two, if you add those, that's 87. So that's 122. And that's the answer. All right, so that one, at least that time, we were given the number that goes inside the rectangle but outside the circles, right? Inside the universal set but outside any of the individual sets that are inside of it. And that helps, right? It's hard to forget when you're told 51 own neither, but that's not always there, right? So sometimes you do have to kind of piece it together. This problem was phrased in a way where it couldn't have been done that way, because if it was one where you would have to figure out this number, you'd have to be given the total number of people surveyed, and that was the thing we were trying to solve. So for this problem, this had to be given, but sometimes it's not, right? And then you have to figure it out. Kind of like in number one, we had to figure out that 15, even though we didn't actually end up using it. But that was one where it wasn't given, right? But you can still figure it out. All right, number 3, there is an awful lot happening here. This is one where there are 3 sets. So you're going to have like the 3 circles in the Venn diagram, and then 3 double intersections, and the 1 triple intersection in the middle. So we got an awful lot happening. Okay. So let's see. I guess we'll make the picture, and we'll start working inside out, and we'll see where we get. I think that would be the best thing to do. All right. I guess I should make this one kind of big because there are going to be 3 circles in it. So circle number 1, circle number 2, and circle number 3. I hope that's big enough. And I guess this would be just in the order they show up: English, history, math. So I would say that's E, that's H, that's M, and that's U. All right, let's see. 13 only English, 12 only history, 15 only math. You could actually put those in right away, but I don't want to be hypocritical and go against the work inside out thing, but you actually could here, because it says only, right? The only English is this part out here that's not in the overlap, but we'll put those in a minute. And then this is a double intersection, right? History and math, but not English. Let's see, 4 taking all 3. Good. There's the triple intersection, right? Because that's English and history and math. So that's where the 4 goes. Okay. 3 are taking none. I guess we could put that one in now too, because we know that's just going to be out here somewhere, right? Because none is in the universal set, but not in any of those 3. Let's see. Other than that, the double intersections. All right, 5 taking history and math, but not English. Let's see. History and math, but not English is this piece right here, right? Because it's got to be in the history and math intersection, but not English, so not overlapping with the E circle. So that means that this right here is a 5. All right, then 6 taking English and history, but not math. That's this piece right here above the 4. Because English and history, we want to be in that overlap, but we don't want it to overlap with the math circle. So it's this piece right here. Then we're trying to solve for this one, so I guess we're not going to get it. But then it's 13 taking only English, 12 taking only history, 15 taking only math. And we're solving for this right here. But we know that the total is going to be 65, right? So basically what we can do is we could add up all these numbers that are in here, figure out what that is, and then subtract from 65, and then we'll get the missing piece. So I suppose what you would call this, and you don't have to do this like when you're going through the homework, you don't have to write this in set notation, but the thing that we're trying to get, I suppose, would be the cardinality of, so it's English and math, but not history. So either like that, or you could do it as a difference, right? So there's English and math, and then subtracting history out. Or you could write it as, and I guess I need an extra set of parentheses, English and math and history complement, right? There's English and math and not history. So either way you want to write that, if you want to write it in set notation, The important thing is if we know we're going to start with 65 and then subtract off the sum of everything else. So 3, 13, 6, 12, 4, 5, and 15. That's a whole lot of numbers to add up. Let's see, it's 20, 24, 36, 42, and 20, and 16 is going to be 58. So that's 65 minus 58, which is 7. So that's the thing that we're looking for. So that's the number who are taking English and math, but not history. And I guess if you want to double check it, you could. If you added 7 plus 3 plus 13 plus 6 plus 4 plus 12 plus 5 plus 15, you'll get 65 back out, and that's what you want here. All right, number 4. So this is going back to 2, because it's only first question, second question. And so that means we don't need a picture that's quite as big. That's why number 4 has a little bit less room on the page, because the Venn diagram is not as huge. Or it doesn't have to be as huge. I guess you could make it that way. I'll still make it kind of big. So, all right. So I guess I'll just call these first question and second question. Right? I mean, you don't have to just use like one character labels for the sets if you don't want to. And I know we always just use like A and B or S and T and things like that, but Q1 and Q2 to me feels more natural here, so I'm going to go with it. And we've got that 115 students got the first question correct, 15 got neither, 75 got both. All right, if we're going to work inside out, there's the both, right? So that's the intersection. That's first one right and second one right. So that means we got 75 in there. And 15 had neither, so that 15 is out here, right? It's outside the circles, but inside the universal set. And we know 115 got the first one right. So in the Q1 circle, we've got to have a total of 115. We already got 75 in the overlap, and that means we need 40 out here, right? 115 minus 75, that'll give you the 40. Or looking at it from the opposite perspective, 40 plus 75 will give you the 115 back. All right, the thing that we're supposed to get, the final answer isn't actually the missing piece, it's what you would have in Q2 entirely. So what we're going to do is just figure out the missing piece and then go from there. But what we would have for, I guess, if you were going to write this symbolically, and again, you don't have to do this, but it feels weirdly incomplete for me not to. I guess we're looking for Q2 intersected with Q1 complement, right? So the part of Q2 that is not in Q1. And we know there's a total of 150, right? And this is the only option that's not covered. Because we have both, we have neither, we have Q1 but not Q2. Now we need Q2 but not Q1, right? That's the only piece that's missing. So 150, since that's the total, right? It says it in the first sentence, given to 150 students, minus what you get when you add the rest of those up. So 15 plus 40 plus 75. And if you add these up, that's 130, right? Because it's 115 plus 15. So this is going to end up being 150 minus 130, which is 20. Right? So we know that's what goes up in here. And I guess I can write this in. This is going to be a 20, right? That's the thing we just solved. And then we want the number who got, so the number who got the second question correct. So I'll just say number who got Q2 correct, which if you wanted to write this as a cardinality, it would just be N of Q2. And Q2 has two parts, right? The part that's in the overlap with Q1 and then the part that's not. And you've got to add those two together to get the cardinality of the whole Q2 circle, which would be the number of students that got the second question right. So that's going to be 75 from the overlap plus that 20 that we just got. And so the answer is 95. All right, last one here. Of 200 people surveyed, 75 or 73, been to California, 47, been to Florida. And then we're talking about California and Florida again, but then there's Maine. So this is going to be 3 circles, right? Because we've got 3 different events here. Like going to California, going to Florida, going to Maine. All right. So big Venn diagram because we got to put 3 circles on it. All right, so I guess the order they show up: California, Florida, Maine. All right, let's see. And like I said, you could put the onlys in at the beginning if you felt like it. So like California only, that's not going to be in any overlap. It's going to be out here. So that's 73. And then Florida only is going to be 47. So that's in the F circle, but doesn't overlap anything else. These doubles we're going to have to wait because we're going to need the triple intersection to figure them out. So 3 have been to all 3 states, so that's a 3 in there. 26 have been to none, so 26 in the universal set rectangle, but in none of the circles. Then we should be able to figure the double intersections out. And the thing we're trying to eventually get is Maine only, so the part of the M circle that doesn't overlap. But we can get these 3 pieces here because we know if we go back up, 17 have been to California and Florida. So California and Florida intersection is here, right? It's this football shape. We've got 3 here. It's got to be 17 total. So that means there has to be a 14 there. So then that way you get 17 for California and Florida. Then we can kind of do the same thing. 10 have been to California and Maine. So here's the California and Maine overlap. We got 3 here. We need 7 there. So California and Maine, but not Florida. So then that way 7 plus 3 is 10, and then that way that checks out. Then 14 have been to Florida and Maine. So the Florida and Maine intersection is this football right here. And so there are 3 there. We need 14 total, so we need 11 there. All right. Then lastly, we're trying to get this piece, and that's the only part that's missing right now. So for Maine only, and we know there are 200 total, right? Because it says of 200 people surveyed. And then we got to subtract everything out. Oh, you know what? I was going to wear my Maine shirt for this one because of this example. I have actually been to Maine. Not that having a shirt proves it, right? You could order that on the internet or something, but I did actually get it there. Oh well. I'll have to work Maine into something else so I can do it later. But we're just going to add all these numbers together. Right, so everything we've got in there so far, 26, 73, 7, 14, 3, 47, and 11. And then we're going to take that sum and subtract it from 200. Okay, let's see. Let's see, can I do this one in my head? We're going to find out. That's 99, and 7 is 106, and 17 is 123, and that's 134, and 40 is 174, and 7 is 181. So 200 minus 181, which would then end up being 19. And that is the answer. So out of those 200 people surveyed, 19 have been to Maine, but have never been to California and have never been to Florida. All right. So I think with the survey problems, the biggest thing is here, I would absolutely draw the picture. You can do them without drawing the picture, but I think if you don't have the Venn diagram there, it gets a lot harder, especially for these where you have the 3 circles, right? With the 3 set Venn diagram, it's really hard to keep track of this without the picture. So I think that's the biggest thing with the survey problems is even though it feels like that'll make the problems take longer, I think that's deceptive. And if you draw the pictures, you actually end up doing them faster. At least I do. Like, I'm trying to do this without the picture. For me, it would feel really hard. Way harder than just going ahead and making the Venn diagram. So that would be my advice here, is draw the Venn diagrams. I think that makes these easier and faster and, harder to skip over pieces like this 26 out here. So yeah, that's my advice. Draw the Venn diagrams here.